Hello! In this video, we are going to prove the following theorem. Suppose f is a function from a to b. 1. If g is a function from b to a, such that g compose f is equal to the identity relation on a, then f is injective. 2. If g is a function from b to a such that f compose g is equal to the identity relation on b, then f is surjective. Okay, so let's start out our proof by supposing f is a function from a to b. Okay, and now let's prove 1. In 1, we're trying to prove if this is true, then this is true. So let's suppose g is a function from b to a such that g compose f is equal to the identity relation on a. Our whole goal now is to prove that f is injective. Okay, so what does it mean for f to be injective? Well, if we recall, what that means is for every two elements, x1 and x2, in A, if f of x1 equals f of x2, then x1 equals x2. So to prove f is injective, this is the statement we're trying to prove. And we're trying to prove a statement about every two elements in A. So give me any two elements of A. I'll call them x1 and x2. And with these two elements, x1 and x2 in A, we want to show if f of x1 equals f of x2, then x1 equals x2. So let's assume f of x1 equals f of x2. And from here, we want to deduce that x1 is equal to x2. Turns out, we're actually ready to do that with a chain of equalities. And to see how it comes together, check this out. Now, x1 is an element of A. So, the identity relation on A evaluated at x1 is equal to x1. But since g compose f is equal to the identity relation on A, the output value yielded by the identity relation on A through x1 is the same output value that g compose f yields through x1. But if we recall from composition of functions, g compose f of x1 is the same thing as g of f of x1. But then, since f of x1 equals f of x2, we can replace the f of x1 here with f of x2. But again, by composition of functions, we know that g of f of x2 is the same thing as g compose f of x2. And since g compose f is equal to the identity relation on A, well, we know that g compose f evaluated at x2 is the same thing as the identity relation on A evaluated at x2. And we know that the identity relation on A evaluated at x2 is equal to x2 itself. So, through this chain of equalities, we see that x1 is equal to x2. Exactly what we wanted to prove. This proves that f is injective. So this proves 1. Now we're going to prove 2. And for 2, we're trying to prove if this is true, then this is true. So let's suppose g is a function from b to a such that f compose g is equal to the identity relation on b. Our goal now is to deduce that f is surjective. What does it mean for f to be surjective? Well, if you recall, what that means is for every element y in B, there is an element x in A such that y is equal to f of x. So to prove f is surjective, this is really what we want to prove. And we're trying to prove a statement about every element in B. So give me an arbitrary element in B. I'll call it y. Now, because y is an element of B, and g is a function from b to a, I'm just going to let x equal g of y. And because x is an output value of the function, g, we know that x is an element of A. Now, remember, our whole goal is to show that f is surjective. And to do that, well, we give ourselves an arbitrary element y in B. And with this arbitrary element y in B, we want to show that there is an element x in A such that y equals f of x. Our claim is that it's going to be this element x in A that satisfies y equals f of x. So we're going to show that y equals f of x. And we're actually ready to do that with a chain of equalities. To see how this comes together, well, first of all, since y is an element of B, it follows that the identity relation on B evaluated at y is equal to y. But since f composed G is equal to the identity relation on B, we know that the output value that the identity relation on B yields on y is the same output value that f composed G yields on y. But from composition of functions, we know that f composed G of y is the same thing as f of G of y. But now, since G of y is equal to x, it follows that we can replace G of y here with x. And we get that y is equal to f of x. So, there is an element x in A such that y equals f of x, namely x. So we have proven this is true. Since y was an arbitrary element of B, this means for every element y in B, this is true. So we have successfully proven that f is surjective. And so this completes the proof of 2, and so this completes the proof. And yeah, that's pretty much the idea of how you could prove this theorem. And yeah, that's pretty much it for this video.